Hey guys, welcome back from spring break. Today we are talking about variation functions. So variation functions are really just like basic ratios for direct variation, but we're also talking about inverse variation, which basically means we're going to have some where we're dividing for inverse variation, multiplying for direct variation. Let me dive in and talk about it in a bit more detail. So in other words, for direct variation, we start off with y equals k times x, where k is what is known as the constant of variation. In other words, it's just kind of the thread between our two numbers. It shows the relationship. So like the constant of variation for direct variation between 2 and 4 would be 2, because 2 times 2 is 4, and then 4 and 8, and 8 and 16, right? It's kind of that relationship between those two. In other words, as one value increases, the other increases as well. For direct variations, one goes up, the other goes up. And as the value decreases, the other decreases. Okay? So, for instance, take a look here at number 1. It says, suppose that A and B vary directly. So that means that I can write an equation that has A equals K times B. They vary directly, just multiplied across, and K is the relationship between those. Now, if A is 6 and B is 3, so let's say A is 6 and B is 3. Notice how I just replaced A with 6 and B with 3. What is B when A is 14? Okay, so let's see here. What I can do here is I can be like, okay, to be able to solve for this, we need to find my constant of variation. So if I know what A and B are, I can use A and B to find a constant of variation, and that constant will apply to all A's and all B's later on. So let's see here. To solve for my K here, I'm going to divide this side by 3 and divide this side by 3, and I'll get K equals 3. And let me rewrite that like that. So there's my constant of variation, K equals 3. Now I can take that constant of variation and use it for my new A and my new B. So my new A says, what is it when A equals 14? Well, let's rewrite our equation, but let's have K be my constant, 3 be my constant this time. So we have A equals, and I'm going to put 3 in instead of K times my B. See how that works out? Now I can take my new value for A, plug it in for A here. I can have 14 equals 3B. And now all I need to do is divide both sides by 3. And we're going to get my new B. My new B is going to equal 14 over 3. So what does the new B equals? It equals 14 over 3. All right? So that kind of shows you the relationship. As one increases, the other also increases. 14 over 3 is indeed bigger than 3. Okay? All right, let's move on down to inverse variation. So inverse variation is division. We are dividing the constant by my values. Okay? So it looks like this. We have y equals k over x, and k is still my constant of variation, but you'll notice here that I am dividing it instead. The reason we're talking about this now is because you have seen a division of x whenever we solve our rational equations, so we know what to do. Okay, so the way this works out, as one value increases, the other decreases, goes down, and as one value decreases, the other increases, goes up. Okay, so take a look here at number 2. I know that I'm going to use this formula, y equals k over x, because it says D and E vary inversely. So I'm going to write it out like this. I'm going to go D equals, the inverse relationship is going to be k divided by E. Now it says D and E are 5 and 1. So I can put those in here and solve for what my constant of variation is, and then I can use that constant of variation to solve for any missing piece that I'm looking for. So we're going to plug in 5 for D and 1 for E, and we're going to solve for K now. Now, To solve for k, I'm going to multiply to clear out that 1. So we're going to multiply both sides by 1. That doesn't really change anything. We just get k equals 5. So my constant of variation is going to be 5. So that is my constant of variation, k equals 5. So I can rewrite my equation with my constant of variation in there. So my original equation, I can rewrite it instead as d equals 5 over e. So now for any value of d or e, we can solve for the other one. And so now when it says, what is e when d equals 15? Well, I just plug in 15 for d here. We have 5 over e. To solve this, we're going to clear out this fraction by multiplying by the bottom, by multiplying by e, which we're going to do the other side as well. So I'm going to multiply both sides by e. And we're going to get 5 equals 15e. Now just divide both sides by 15. And we get e equals 5 over 15 can reduce to 1/3. So we get k equals 5. My constant of variation equals 5. And that allows me to find my missing e. So I want you to notice something here. Notice how to get from from 5 to 15, I multiplied by 3. And to get from 1 to 1/3, I divided by 3. Do y'all see how those are inverse of each other? As one goes up, the other goes down. Let's put this into practice. Take a look at number 3. Suppose that y and x vary inversely. Now you're going to be looking a lot. Is it direct? Is it inverse? Is it direct? Is it inverse? We don't know. So this one says it's inversely. And x equals 5 when y equals 7. Which function models the inverse variation? So remember, formula for inverse variation is y equals k over x. Y equals k over x. So then we're going to say, okay, that means x is 5, y is 7, so we can plug those in. We can make y 7 and x 5. We're solving for my constant of variation, so all I need to do here is multiply both sides by the bottom, and 7 times 5 is 35. So we're going to have 35 equals k. All right, so that's my constant of variation. You'll notice that's not an answer over here. So we need to know how to put it back together. So now if I rewrite my equation, we can replace the k with my constant that's here. So I can rewrite it as y equals 35 over x. And that definitely is one of my answers. It is C. Okay? All right, now let's apply this. Let's take a look at some real-world problems. Number 4, the amount of chlorine needed varies directly as the water needed to fill a swimming pool. If 5 units of chlorine is needed for a swimming pool that holds 55 gallons of water. So let's just throw this out here. First off, it varies directly. So we're going to be working with y equals k times x. And we're going to make these 5 units of chlorine. Let's make this my x value. So my x for my first problem is going to be 5. And then let's make this holds 550 gallons of water as my y value. So then, if I know it varies directly, we can write our equation. We can have 550 equals k times 5. We're just replacing there. Now, we're going to solve for my constant of variation. We're going to divide both sides by 5, and I'm going to get k equals 550 divided by 5 is 110. So that is my constant of variation. My constant of variation is 110. My next question, though, is find the amount needed for 850 gallons of water. So let's rewrite my equation. Let's rewrite it as y equals 110 times x. And we're looking for this time 850 gallons of water. So my new y is going to be 850. So we're going to say 850 equals 110x. We can then divide both sides by 110. and we can see how many units of chlorine that we need. So 850 divided by 110 gives us 7.72 repeating. So how many units of chlorine do we need? We need 7.72 repeating units of chlorine. Okay? All right. Now, moving on. Our next one, number 5, says the hours H that it takes to reach your destination varies inversely. So this one's an inverse problem. So we're going to be using this formula, y equals k over x, with your average speed s. So we could instead of using y and x, we can instead use h and s. I could go h equals k over s. Doesn't matter. We can write it like that. Suppose that it takes you 5 hours to reach your destination. So we could say 5 hours to reach our destination, and our speed is 60 miles per hour. Just multiply both sides by 60, and you get 300. So my constant of variation, here I am multiplying both sides by 60, and my constant of variation is 300. So I can rewrite my equation. And instead of having just k, we're going to go h equals 300 over s. And then now, it says, how many hours would it take to reach your destination if you were going 75 miles per hour? So if I instead, here's my hours, here's my 300 over my speed, which is 75. So once again, I can just grab my calculator, and I can go 300 divided by 75 is 4. So how long would it take us to reach our destination? Well, we're showing the inverse variation. As my speed goes up, my time goes down. So it's going to take us now 4 hours to reach our destination if I go 75 miles per hour. Okay, now for our last question, number 6 here. So number 6 says the area of a triangle varies directly with the base and the height of a triangle. Okay, so my area varies directly with the base and height of the triangle. For a triangle that has an area of 16 units, the base of the triangle is 8 units and the height is 4. So we can go 8 times 4 is 24. Divide both sides by 24. So we got k times 24. Divide both sides by 24. Goodness sakes. Learn to do math, Mr. Martin. You're only a math teacher. 8 times 4 is 32. Silly me. Okay, so now we divide both sides by 32. And we get k equals 1/2. So that's going to be my constant of variation. My constant of variation is 1/2. So then, what is the height of a triangle that has an area of 25 units and a base of 10 units? We can plug in my 1/2. So let's see here. So we can go my area, we have my k, we have my area. My new area is 25 units. So we can go 25 equals, my k is 1/2 times my base is 10, and we're looking for the height. So 1/2 times 10 is 5, so we'll have 5h equals 25. Now all I need to do is divide both sides by 5. Divide both sides by 5, and we get our answer of h equals 5. So the new height for my triangle is 5 units. All right, guys, inverse direct variation. Think about the changes as it goes. Look on Go Forward to help you find the answers and to see how to write out those inverse and direct problems. All right, guys, it's good to have you back. Have a great day.